So hello guys, welcome back to my channel. So today we'll be solving question number 4 and onwards of 5070 variant 2 paper 2 October November 2023. Okay, so let's begin. Okay, so question number 4 part A. It says that concentrated aqueous magnesium iodide is electrolyzed using graphite electrodes. Okay. Predict the product at each electrode. So here we can see that we have concentrated but aqueous magnesium iodide. So our main focus is aqueous, right? Just ignore concentrated because here we have aqueous, which means that at the cathode we'd be having hydrogen for sure. Let me write it. And at the anode we'll have iodide because its relative discharges, it easily discharges then, OH, which, further uh, becomes oxygen. So here we'll write iodine. Okay. Okay, so now we have molten magnesium iodide, which is being electrolyzed using graphite electrodes. As it is molten, which means no water is present. So what will directly, okay, here we have to, uh, construct the ionic equation. So for that, we need to know that what will we be getting at the anode and cathode. Okay. So as there is no water, we have magnesium and iodide. So at the cathode, I'll write first. We'll have Mg2 plus ion. Okay. So what we'll do, as it has two less electrons, so we'll add two electrons to it, which will make it what? Magnesium. And here at the anode, we'll have iodide, and we have to make iodine. So here we have two iodine. So here we'll place two and two negative. I mean like two extra electrons. So make it neutral. Two electrons will be removed. Okay. So let's move towards the next part, which is asking us that describe a test for aqueous iodide ions, include the observation for a positive result. So we have studied in our qualitative analysis notes that we can add acidified silver nitrate, and the observation would be yellow precipitate. I'm just writing PPT. You have to write full form precipitate. Okay. So let's move towards the next part. Iodide ions reduce manganese. Okay. Manganese 4 oxide MnO2 to Mn2 plus ions. Explain in terms of electron movement of electrons how iodide ions act as a reducing agent in this reaction. Okay, so here we should know that what basically reducing agent is. So let me write it for you here. Reducing agent is basically the one which is which reduces the other but oxidizes itself. So you have to keep in mind this thing. Okay, so Here we can see that they are even telling us that iodide ions reduce. Okay, so 2I minus MnO2, we have to, look, let me highlight. All right, so let's do this, and this becomes this. Okay, so we have to tell in terms of electron movement. So here we can see that there are two electrons, one iodide ion has one electron, and here we have two iodide ions, so two electrons. And here at the product side, here we have iodine, which is in its elemental form, which means like two electron here, two and zero extra electrons here, which means iodide has lost two electrons. And here we can see that uh, oxygen has two minus, and here there are two, so four minus, which means manganese would be 4 plus. Okay, so manganese has 4 plus, and here you can see it has become 2 plus, which means like here it had 4 less electrons, and here it has 2 less electrons, which means it has gained 2 electrons. And we know that, as it is also given in the question, that it has gained these electrons from iodide, due to which iodide became iodine, and manganese 4 plus became manganese 2 plus. Well, not manganese 4 plus because it's MnO2, but the oxidation state is 4 plus. Now it has become 2 plus. Okay, so let me write it for you. Okay, so what will I write? I will write it like iodide ions give electrons to Mn in MnO2. Okay, so okay. Next, the next part, what they are asking us that state the name, state the name of the type of reaction. So here we are being asked. Uh, okay, so in part two, we are being asked that state the name of the type of reaction that involves simultaneous oxidation and reduction. And we know that it is called as redox. So I'll write redox. Okay, so let's move towards the next part. Part E, phosphorus triiodide is produced when phosphorus reacts with iodine. Complete figure 4.1 to show the dot and cross diagram for a molecule of phosphorus iodide. So we know that valence electrons will be full. I mean, like they are bonding, so they'll be full. So for that, what I'll do, I'll first draw outer electrons, right, for phosphorus. I know that it's, atomic number is 15, so it will have 5 valence electrons. And here I know that it makes one bond only, single covalent bond, I mean. Okay, so let's move towards question number 5. Okay, so question number 5 is asking us that figure 5.1 shows the displayed formula of compound A. Part 1 on figure 5.1. Draw a circle around the functional group that reacts with aqueous bromine. So here we can see we have two functional groups, OH and C double bond C. But we know that only C double bond C will be reacting with aqueous bromine and will be decolorizing it. So let me circle. Okay, part 2, describe the color change when excess compound A is added to a few drops of aqueous bromine in a test tube. As I told you earlier, that C double bond C will react with aqueous bromine and decolorize it. But here they are asking the color of aqueous bromine, so we have to write here that the color is orange. Okay, and color after addition of compound A, I'll write decolorize. Okay, so next is reduce the molecular formula of compound A. Okay, so uh, compound A, let me count number of carbons. 1, 2, 3, 4. Four carbons. 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen and 1 oxygen. So that would be C4, H8. The compound is a liquid at room temperature. Describe the motion and separation of the particles in a liquid. So motion is basically like how the particles will be moving. So we write that they'll be sliding over each other. And separation, like how there'll be like the distance between the particles, we may say. So we can write that will be close together. Right. Okay, all right. So next part B, figure 5.2 shows the structure of compound B. Compound B is polymerized. Draw two repeat units of the polymer formed when compound B is polymerized. Okay. So here addition polymerization is taking place, and now the double bond is between carbon number 2, 1, 2, 3, and 4, between 2 and 3. So how we can draw, and we have to draw two repeat units. All right, so how we can draw? Now I have to draw in such a way that at one end, carbon number 2 should have a one valency, and at the other end, carbon number 3 should have one valency, to which no further repeat units can be attached. So I can draw it like this, and here let me draw hydrogen first. And three, 1, 2, 3, and here I'll have okay, one valency, and okay, 2, 3, 4, 1, 3, sorry, not here. 1, 2, 3. Here another. So C, and sorry, and here second repeat unit. So that would be same. Now we'll draw it same, the same, like shape. And 1, 2, 3, 4. H, 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 and an H here. Sorry, not here, because it would be the. So 1, 2, 3, 1 H here. Sorry. And 1 H here. Yeah. So be the. Okay, so we've done this. Okay. Okay, so our next question is that describe two environmental challenges caused by the disposal of plastics. So we can write that like now when the plastic is burnt, so toxic gases are formed. So during burning, and two could be landfills. So we have this is the end of our question number 5. Okay, so I hope I was able to explain it to you, these two questions. Um, so I hope it's clear, and if you still have any query or confusion, so you can comment down, and I'll try to clarify the the misconception or the query or anything, any problem. I'll try to solve it. And okay, so we'll meet you in the next video. Till then, take care, and do remember to like, share, and subscribe. Okay, then, till then, have a good time.